Good morning and welcome to our project submission video for CS410. My name is Rahul and I'm based in Singapore. My project partner is Prabhu and he's working in Amsterdam. The project proposal for this semester was Sensitive Data Identifier, and as we all know, data privacy has been a very important domain of concern in the modern world of big data technology. Both governments and regulatory bodies across the globe in recent times have established several norms that mandates to restrict enterprises from misusing the consumer sensitive data. As a result, most enterprises have been executing remediation projects that are aimed at securing, removing, or masking sensitive data. So the objective of our project is to build a text analysis utility that would basically pass through data and alert if there's a presence of sensitive data fields. We could be looking at social security numbers, address, credit card numbers, phone numbers, email addresses, etc. And the model should basically be able to, will be really useful for firms and organizations that have large data source, and they need to remediate sensitive data in accordance to some of the regulations in their country, such as the GDPR in Europe, PDPA in Singapore, etc. So without further ado, let's jump to the GitHub page where I can show the where the repository is located. So this is our GitHub page, and as I mentioned, the motive is to have two modes. One, it can work as a plug and play Python library where you can give it a string and it can basically tell the presence of sensitive data, and also work as a batch mode where ideally you can give it can keep running in the background, looping through different files in your storage, and find out if there's any sensitive data present in those files. And ideally, the output should be presented in a simple, easy to read manner. And obviously, there has to be some monitoring setup as well, which can alert the relevant teams. One of the important aspects of how we need to be smart with our data, as we all know, data is our biggest asset, is we need to minimize what we collect and store or copy across the network, and being able to classify or automatically redact the sensitive data from either your text streams before you write to the disk, or from your logs is really helpful. And as I mentioned, alerting the users before they save the data or before they send out that email which has the sensitive information is really critical as well. So the another usage of this particular script could be if you're auditing unstructured data sets, and you can use this library to find out if there's any sensitive information. And this can work as a precursor to the IT remediation project. So currently our tool is inside a Jupyter notebook, and as I mentioned, but in two production scenario, it will be basically running as a Python library to run in the batch mode. And we have a bunch of APIs which are exposed, and they can tell you the different fields which you might be interested to look at. So why don't I take you to the actual Jupyter notebook page, and then we can basically do it on interface level. Okay, so this is our Jupyter page, which we have uploaded to the Git page as well. I would like to start off with the magic itself, where I will have this text here, and it talks about different things, as you can see, names, addresses, and some numbers there as well. So why don't we call the function, which is the main function to get the sensitive data, before we jump into each of these embedded APIs. So I call the function find sensitive data, and I pass the string to it, which is in our case Muggle text. Um, and let me just run this. So as you can see, very quickly it was able to pass the string and tell you the different fields which the algorithm thinks are present. A Singapore ID is a very critical. It's like a social security number, which is critical and sensitive. And as you can see, it has been able to find out if there's any Singapore ID in the text. It can also find out if there's any Twitter handle which is present in the string. Um, as you can see, it has also been able to find out the email addresses, any embedded URLs, phone number, and later on I'll show you that there are different formats of phone numbers which the algorithm can pick up. And this is just one of them. This is the plain number format, and you can see that there is location which is present as well, credit card number, and another credit card number. And in this case, it has been able to find out if this is American Express or not. A small little reg exchange to differentiate between American Express and the other available providers. There's another text here. Why don't I run the same thing on this as well, just so that we have more things to see. And sorry, here we go. So as you can see, it has been able to find out some more information here. Apparently, this string was bigger. It is able to find out different Singapore IDs, Twitter handles, emails, URLs, different formats of phone numbers. As you can see here, one with dashes, one without dashes, locations, credit card numbers in different formats, and also it is able to find out if a particular credit card is American Express or not. So what we can do now is just very quickly go into each of these API calls and maybe just run it in form of a demo. So the function find emails, as you can see on my screen, you give it a string and it can find you if there's any email sensitive email content in the text file. Here it has printed out our university addresses. As you can see, it can also find out phone numbers, and there is a regex function here. So if you have specific phone numbers which have extensions or a different format based on the country code, it can be very easily tweaked to find out these phone numbers. It can also find out, as I mentioned, web URLs, and once again, it can basically find out if the same URL is given in different format without the HTTP or HTTPS or different suffixes as well. One of the things we also tested is for social security numbers for Singapore, and as you can see, it is able to find out Singapore ID, Twitter handles. Here we have Gandalf, and locations. Credit card numbers, and if I pass the same credit card number in different format, it should be able to find that out as well. I'll just show you a quick demo of that. And if I run the same thing again, this should be able to find, that this number is an American Express number because it has a different format. and it has a different signature. Uh, Another thing which is there is organization. It can find out if the person is working for a particular organization, and yeah. So one of the things which I would like to mention is specifically on how these APIs are written. We have used various available techniques of combining NLTK libraries and regexes. And specifically, if I want to talk about, say, organization or location, or a bunch of them, it's basically using the NLTK pause tag. Now, as we all know, um, part of speech tagging is really important for syntactic and semantic analysis. For example, if a sentence has the word can, it can have several different semantic meanings. So, one just to bring up an example, it could be either a modal for a question formation, or it can be a can, which is like a container, or a verb, which denotes the ability to do something. So, given a word in this specific meaning, allows the program to handle it in the correct manner in both semantic and syntactic analysis. So, we have used pause tag, and another thing which we have used is the NLTK any chunks. So as you know, chunking is a technique which segments the segments and labels with multi-token sequences, and these chunks like tokenization. In tokenization we omit white space, but in chunking we usually select a subset of tokens, and similar to tokenization, the pieces produced by a chunk do not overlap in the source text. So we in our case we have used any chunks. So NLTK provides classifier to which that has already been trained in some ways to recognize named entities, um, and we can access these functions by the NLTK any chunks. And we have used NLTK any chunks without the binary flag, so that it can tell us whether a category is person, organization, or location. Um, and that is one of the NLTK things which we have used in our APIs. So as I mentioned, this was the plug and play functionality of our algorithm. But another small feature which we have done is to simulate how it will run in the batch mode. So as you can see on my screen, it will fire off the API back to back on each of the files on the data set. Obviously, this can be, there's a lot of scope for enhancements on this to leverage cloud, or even in fact even use the GIL multi-threading as well, so that it can run on different files at the same time. And we pass the list of files here, which have random data, and we want to basically check if these files have any sensitive information which is getting embedded into these. So we loop through each of the file. We analyze the pause tags and evaluate the risk of each word. Why don't I just run this and show you the output? So this is the output which gets generated. And as you can see, it can tell you which document is getting processed, the name of the document which is getting processed on, the total number of files, and this would probably help if you want to do worker-based segmentation and bucketizing, that every 1,000 needs a different run. Um, and as you can see in the files, which seem to be normal literature files, we could see that there were some sensitive information which was there, like the Singaporean social security number, Twitter handles, email addresses, um, and URLs, phone numbers. As you can see, there are different formats which is able to catch locations. And as I mentioned, the location API needs to get more robust, because right now it's only working on single word level. But hopefully, we can enhance it to work on multi-line text as well, so that it can catch the entire address as one entity. Uh, It can also find out credit card numbers, as you can see here, again in different formats, American Express and others, and so on and so forth. And it loops through all the different files, as you can see, and outputs all the different information which it finds. Um, we can enhance this also by putting some monitoring on it so that it alerts if there is any sensitive information found, and also if the assigning weights. So finding a credit card information on the in the file is very sensitive as compared to finding a location, right? So we need to assign weights to ensure that we can properly figure out the risk attached to each text file and take decisions based on that. Um, so that's pretty much the batch mode which I just showed. It can run and alert us, and it can loop through different files. But while doing this project, we also um, analyzed the Google DLP API, and as you are all aware, data is the biggest asset, and all these firms are trying to get more smarter in the way they handle your data. And the Google DLP API is basically which allows you to minimize once again what you collect, store, and expose or copy across the network. And it is scalable, so it works on cloud. It can classify and redact your sensitive data, and Google has its own set of data providers, which are basically these APIs which it can use to find out sensitive data. And we have mentioned that on our technology review as well. Um, one of the features which we thought would be very useful once we enhance this sensitive data identifier algorithm is not just it should be able also be able to handle to classify incoming sensitive data, even if it has not seen something like that before. So using sentence similarity features, using TF, IDF, and K-means to basically find out how the incoming sentence is similar to any sentence which it has seen in its training data set. With that, it will get more smarter in handling unstructured, unseen sensitive data. With that, I would like to end the presentation, and we would like to thank you for spending your time to check this out. For any questions, feel free to reach out to both of us. The email addresses are provided on the GitHub page as well. Thank you.